Hello all. Today we'll be discussing about accessing database. This presentation provides a comprehensive overview of database access from establishing connections to optimizing performance. We'll delve into best practices, error handling and security considerations for seamless integration. Importance of database integration. Data storage and retrieval. Database provide a structured and efficient way to store, organize, and retrieve large amounts of data. Data integrity and consistency. Databases ensure data accuracy, consistency, and reliability, preventing data loss and errors. Data sharing and collaboration. Databases facilitate seamless data sharing and collaboration among different applications and users. Data analysis and insights. Databases enable powerful data analysis and reporting, uncovering valuable insights and trends. Establishing database connection. Choose a database system. Select appropriate database system based on your application requirements such as MySQL, PostgreSQL, or MongoDB. Install and configure. Install and configure the chosen database system on your server, ensuring appropriate security measures. Establish connection credentials. Define database connection credentials, including hostname, username, password, and database name. Test connection. Test the connection to ensure a successful and secure communication link between your application and the database. Querying the database. SQL syntax. Use SQL, structured query language, to interact with the database, sending commands to retrieve, insert, update, or delete data. Query types. Employ various SQL query types, including select for data retrieval, insert for data insertion, update for data modification, and delete for data removal. Data manipulation. Manipulate data within the database using SQL commands, ensuring data consistency and integrity. Handling database responses. Retrieve results. Fetch data from the database using SQL queries and store the retrieved information in appropriate data structures. Parse and process. Parse and process the retrieved data to extract valuable information. Transform it into the required format and prepare it for further use. Error handling. Implement error handling mechanisms to gracefully handle any database related errors, preventing application crashes. Securing database access. User authentication. Implement robust user authentication mechanisms to control access to the database, ensuring only authorized users can interact with it. Data encryption. Encrypt sensitive data both in transit and at rest, protecting it from unauthorized access and breaches. Access control. Establish fine grained access controls to restrict user permissions based on their roles and responsibilities. Regular security audits. Conduct regular security audits to identify and address vulnerabilities, ensuring ongoing protection for your database. Error handling and exception management. Connection error. Unable to establish a connection to the database. Handling approach. Retry connection or handle the error gracefully. Query error. Invalid SQL query or syntax error. Handling approach. Log the error, display an appropriate message, and attempt to recover. Data integrity error. Violation of data constraints or integrity rules. Handling approach. Validate data before insertion, implement error handling, and roll back transactions if necessary. Optimizing database performance. Index optimization. Create appropriate index to speed up data retrieval by allowing the database to quickly locate specific data records. Query optimization. Analyze and optimize SQL queries to reduce query execution time, improving overall performance. Caching. Implement caching mechanism to store frequently accessed data in memory, reducing the need to constantly access the database. Hardware optimization. Ensure sufficient hardware resources such as RAM and storage to support the database's workload and performance. Best practices for database integration. Database design. Plan a well designed database schema, ensuring data normalization and optimal table relationships. Code structure and documentation. Maintain clean, well documented code for database access, enhancing maintainability and understanding. Performance monitoring. Regularly monitor database performance metrics, identifying and addressing bottlenecks to optimize performance. Conclusion and key takeaways. Database access is essential for modern applications by adhering to best practices, ensuring security, and optimizing performance. You can leverage the power of databases to build robust and efficient applications. Thank you.